Assalamualaikum and hi. My name is MOHAMMAD ZAMRI and my metric ID is MA25010. So now, we want to present our statics project, which is the structural analysis. The problem that we encountered is the roof beam. So, this is the picture of the roof beam. Before we move to the solution, we must need the FBD. That's right, the free body diagram. So, this is the free body diagram that we have drawn. So now, let's move to the solution.
Hi, I am RAIF, MA25001. Next, I am going straight into the equilibrium rigid body of the roof beam. First, we need to analyze and break the forces into multiple resultant forces, since all the forces are not in the axis, and label them. We're gonna break them into axis using theorem in the beam. Firstly, finding summation Fx, we need to list all the forces are in the x-axis. Based on my calculation, I already list them, and as the final result obtained was Hx equal to 0. Furthermore, summation of Fy, same goes to x. I already list all the forces acting on y-axis and obtaining equation with unknowns Hx plus Gy equal to 107 Newton. Lastly, analyze using moment at H. There were all possible forces that can be done using moment and distance, and don't forget the weight itself. As a result, we obtain Gy equal to 53.5. Lastly, from the equation Fx, Hx plus 53.5 equal to 107. So, Hx is also 53.5. In conclusion, Hx plus Gy is equal to downward forces. So, it is proven that the roof is in the equilibrium.
Assalamualaikum warahmatullahi wabarakatuh. My name is AZAM and my measure number is 25005. So today I will show you how to calculate centroid from a free body diagram. The free body diagram is already explained, so I will jump to the next part, which is we need to decide how many segments that we will split, so that we can know how what kind of formula we will use. So here we have rectangle on the right and left side, and rectangle on the right and left side of our free body diagram. So when we know what kind of shape, what kind of section that have in our free body diagram, we know which formula to use. In this problem, we have rectangle and right triangle in our problem. So we will use this formula in our calculation. I suggest to use a table in this problem because it will make you easier to calculate and find the solution. So here we have 4 segments, and then first we will calculate the centroid of the x-axis of every segment, of each segment. Centroid of y-axis for each segment, and then area of each segment. When we have these 3 information, we will use area. We will times with x and y centroid to get the area of centroid x and area of centroid y. Then we need to calculate the summation of area centroid x and summation of area centroid y. Then when we have these 3 information, we use the formula, which is x centroid equal to area of centroid over area. Then we have this is our solution, our value for the centroid of the whole shape, which is 16.2 for the centroid of x and 2.8 centroid of y. That's all for me.
Assalamualaikum and hi. My name is Arief FAKHRUDDIN bin NORJAZLIZAM, MA25003. I will present the method of section. First of all, we need to cut the structure into two to calculate its external force. Next, we need to draw the free body diagram and define the force that acting on the beam. We know that the forces are FAB, FAP, FHP, and FAH. So now, we can make an equation. First, we can find FHP by calculating moment at A equal to 0. Those are the equation. And then, we get the FHP value, which is 58.91 Newton tension. Next, we can find FAP by using sum of Fy equal to 0. But we notice that there are two unknown, so we let it become equation number 1. So we can skip that for a while. We use the sum of Fx equal to 0, but we got the same two unknown also. So we can define FAH as the subject and make it as equation number 2. After that, we can substitute equation 2 into equation 1, and we get the value of FAP equal to 28.48 Newton compression, and value of FAH equal to 69.7 Newton compression. Lastly, we should find FAB by using some moment at P equal to 0, and we got the value of FAB equal to 176.33 Newton tension. That's all from me. I hope you guys understand well. Thank you.